Hello class, good day, good morning, good afternoon, good evening. Welcome to our lecture number 3 for our subject, statics of rigid bodies. So in the previous lecture, we talked about the resultant of forces, but now we will talk about the resultant of concurrent forces. So more than two forces, and we will have many examples today. So sit tight and may you all enjoy and learn from this lecture material. Okay, let me share my screen. Okay, let's start. Resultant of several concurrent forces. So in this example, we have a screw or a wrench. Okay, you are to determine graphically the magnitude and direction of the resultant of the two forces using our methods, either the parallelogram rule or the triangle rule. The graphical solution, essentially, you will draw. Okay, you will draw. So what we need here actually is a graphing paper, of course, and a correct drawing of your data. Okay, the data given. So in this case, from the example, we will project 600 here, then the 900 newtons here. Then connect the two, we will get the resultant force. But then, since it is on a scale, you should draw it to scale for the graphical solution. R is approximately 1,400. And the measurement angle using a protractor is approximately 46 degrees. So the triangle rule may also be used in graphical solution. So that will be this one, move here, and then connect head to tail, and then connect the resultant from the point of application to the end of the head of 600 newtons here. Okay, so let's solve using the trigonometric solution using first the cosine law. Okay, so the magnitude given are 900 and 600, just square it, minus 2 multiplied by 900 times 600, cosine of the included angle, 135 degrees. So the resultant force is 1,391, so approximately, approximately close, very close to 1,400 newtons. For angle theta, using the sine law, for us to find the what you call this, point of application, the direction, okay? So 30 plus alpha will be the total angle. But then to get alpha, you use the sine law. Sine alpha over 600 newton, the opposite value, over is equal to sine 135 degrees over r, okay? 1,391. So we have r already. Thus, using the inverse, alpha is equivalent to 17.8 degrees. And finally, the directional force will be 47.8 degrees. Okay? Another example. In this diagram, we are tasked to find the P is 35 newtons. We are tasked to find the required angle, to identify the required angle, and the corresponding magnitude of R. But some conditions are given here. Such that the resultant of the two forces applied to the hook support is to be horizontal. So the resultant should be something horizontal. Okay, horizontal. Meaning the resultant force has a directional angle of 0 degrees. Okay, horizontal horizontal degrees. Now, so we have here here, this one, r is 0 degrees, okay? So we can easily solve sine alpha over 50. This one, alpha, opposite magnitude, 50 newtons. Sine 25 degrees, opposite the 25 degrees, is the p value, the value of p, which is, a while ago, 35 newtons. Let me, what's the highlighter? This one. P is 35 newtons. Okay, so determining alpha and beta, so that's easily identifiable. Since this is already one equation, this one is already one equation, and this one is the second equation. So solving further, we get alpha to be 37.14, and then beta, we didn't use this already. We cannot use this since we don't have r yet. So we will use this equation once we get beta. Sorry about that. Okay. Beta is simply 180 degrees, the sum of the interior angles inside the triangle, minus alpha, minus 25 degrees. So solving further, from alpha 37.14, b or beta is 117.86 degrees. Now solving for r, so using this equation, or the other one, sine alpha over 50 is equal to sine beta over r. And we know beta already, that will be 117.86. So r is simply 73.22 newtons. Okay. Again, class, if you will have any questions, you can message me. I will reply. I am always available to you. Okay, next question. Our next problem. A barge is pulled by two tugboats. If the resultant of the forces exerted, so take note of this, we are taking down English unit, okay, English unit. 5,000 pounds directed the axis of the barge. Determine the tension for each ropes for alpha is equal to 45 degrees. And then the value of alpha for which the tension in rope 2 is minimum. So this rope. So we are to minimize this one. Okay, so from the graphical solution, we can simply have the parallelogram law. So opposite internal angles, interior angles rather. Okay, then 45. So we get, for the graphical, 3,700 approximately, and tension 2 is 2,600. But using the law of sines, okay, using the law of sines. So this will be tension 1 equivalent to tension 2. This one will be also tension 2. Okay? So, from our triangle law, this will be our diagram. Okay? 45 degrees, 30 degrees, and the included angle is 105 degrees. So T1 is over sine 45 degrees, the opposite angle, is equivalent to T2, 30 degrees, the opposite, over sine 30 degrees, the opposite internal angle. So solving further, we get the resultant is 5,000. So T1 and T2 can simply be solved. So consider this as your first equation. One equation with one unknown. Okay? And then once you get T2, you can use now that one in order for you to solve the second equation. You can consider this one. Okay? So solving, we get T1 and then T2. Okay? Now, the second condition is kinda hard to imagine. Okay? The angle for minimum tension in rope 2 by applying the triangle and observing should be effect of variation in alpha. So meaning, in order for you to get the minimum tensile force or the minimum tension, we need to get what's the maximum. Okay, what's the maximum? The duality. So you can get the maximum. What is the maximum angle that can be in a triangle like this? You need to have an perpendicular triangle, a right triangle. Okay. So opposite the 90 degrees will give you the maximum magnitude, and then opposite of the minimum angle is the minimum in magnitude. Okay, in that case, this will be our triangle. Okay, so opposite of, we want T2 to be minimum, opposite of 30 degrees is the minimum. Since 30 degrees is the minimum angle in your right triangle, thus, solving further, we can get, note that, let's take note of that T2, the tension in rope 2 should be minimum, okay? So going back, so opposite T2 is the 30 degrees, and then we will get T1 to be 5,000 pounds. So this is just simply your sine law again, okay? Sine 90 degrees is equivalent to 1, okay? That's why we don't have already here sine 90 over, sine 90 degrees is equivalent to 1. So this one, nawala na, okay? It's gone, okay? 5,000 over 1. Then multiply by cosine 30 in order for you to get the magnitude of T1, okay? Since we have a right triangle, okay? Cosine adjacent over hypotenuse, okay? From this equation. So katawa class. So don't forget that. So katawa. Cosine is equal to the magnitude of the adjacent over, that will be T1 over the hypotenuse, that is 5,000. That's why we get cosine 30 multiplied by 5,000. So T1 is equivalent to 4,330 pounds. Now finally, the minimum value of T2, of course, sine 30 is just 1/2. Okay? So 5,000 divided by 2 is simply 2,500 pounds. Okay? Now, some concepts that we need to know or to be reminded. It has been shown that the resultant of forces acting at the same point can be found. In the same way, a given force F can be resolved in two components. There are two major cases. So a singular force can be resolved into many forces as long as those forces passes through the point of application, meaning the point of concurrency. Okay, they are all concurrent on that point. In this case, we have R can be dissolved into P plus Q. In this case, we have F dissolved into Q plus P. Okay? So the two cases, hindi ko pala nabasa. Sorry about that. Laser pointer. When one of the two components P is known, when you know the equivalent value of P, and the line of action is known. Okay, so you can read, you can dissolve it once you have a known value of the other two and the known direction or line of action. In this case, we have a given resultant force of P equivalent to 800 newtons. We are to dissolve it with the forces in the by this one, okay, in this diagram. So we are to identify A, translate B into that location in order for you to get the needed angles to be identified, okay? So 45, what is this? This is your alternate interior angles also, no? So 20, 40. So you know that this one equivalent to 40 degrees. Let me draw in order for you to get, to understand, to get. This will be 40 degrees, the equivalent. And this one is your 40 degrees. Okay? So 40 plus 45, in order for you to identify alpha, 180 degrees, the sum of the interior angles in a triangle minus 45 minus 40, that will be equivalent to, what's that? 95 degrees. Okay? And then, so solving further, we will have this triangle. Okay? Using the sine law, we can simply get now FA and FB. So, treat this as first equation. Now again, treat this as your first equation. One equation, one unknown. And then once you get that, once you get B, you can simply solve for FA. Okay? For this equation. Again, one equation, one unknown. Okay? So many examples. So I hope you're getting you're getting our lecture so far. Okay? So rectangular components for force and the unit vector. Now, one thing we need to understand, since we are dealing with vectors, we can dissolve them, as we said earlier. But at the same time, vectors, you can characterize it from our physics, right? Like in this case, F can be characterized with this term, I comma J. So open bracket, close bracket, like that. But it's the same also as your I hat plus J hat, right? F is equal to I plus J. Okay, so we can resolve it in that way also. So meaning we can identify, when we identify I to be our X function and J to be our Y function, we can easily dissolve it. The X component for the force F is equivalent to F cosine theta, this one, the directional cosine, and then sine for the Y component, okay? So in this case, we have 800 Newton, a resolved force or magnitude resultant. So in order for us to get the X component, that is simply 800 Newtons multiplied by cosine 35. That will be it. And then for Y, 800 Newton multiplied by sine 35 degrees. So this is a trick question kasi. This one, the 145 degrees. So other components that we need to remember, the direction can be identified using this one, okay? Arctangent of Ry over Rx, the magnitude of Ry over Rx, for us to get theta R, the direction of your force. You can also have the resultant of X when you sum all the components of X, of all the forces along the x-axis and all the forces along the y-axis, will give you the resultant force for Y. And then using the Pythagorean theorem, Pythagorean theorem, you can simply get fx squared plus fy squared, the square root of it, will give you the magnitude of F. Okay? So example 7, determine the resultant of the three forces below. So we have 800 Newton, 350 Newton, and 600 Newton. This is very easy, class. This is very easy. Okay? So, medyo mahaba lang. Okay? Let's deal with this, one by one. 350 cosine 25 degrees. What is that? This one. Okay, this force. We are getting the resultant force along the x-axis first. So this one. The x component of this one, 350 Newton. So that will be 350 cosine 25 degrees. This will be it. Okay. Next, 800 Newton. So this one is equivalent to 45 Newton. So since we are getting the x component, that will be 800 Newton cosine of 45 plus 25 degrees. This one. 800 cosine 70 degrees. That will be 273.6. Now, this one, the negative, this will be a negative component since pointing to the left. Okay, to the left. Now, minus 600 cosine 60 degrees. This one, the x component. So, summing up everything, we get 290.8 Newton. Now, for the y, okay, na erase that. Let me erase first. Erase all link on the slide. Then, for the y, let's use laser pointer. The 350 Newton sine 25, that will be this y component. Okay? The y component. So let's use the highlighter. So this force. Okay? That magnitude. And then this one, 800 sine 70 degrees, this magnitude. Okay? That will be 751. And finally, plus 600 plus 600 sine 60 degrees, this magnitude. Now, question. Why don't we have here minus? This is in the left. That is a trick question, okay? We need to deal with only with up and down. So all of this are in the upward positive y direction. Thus, all is in the positive order. Okay, so summing up everything, we get 1419.3 newtons. So the force vector form, 290.8 I hat plus 1419.3 j hat. Okay? And for the magnitude, using the Pythagorean theorem, we know this already. And the direction, angle, arctan of y, or Fy over Fx. So giving us 1449 newtons, 78.4 degrees for the direction. Okay, you have so many examples. Now, a hoist trolley is subjected to the force shown. We are to identify the force P and the resultant of the three forces and the corresponding magnitude of the resultant. The resultant being means vertical means that the horizontal component is 0. Okay, we are now proceeding to the next chapter actually, class. Okay, so in order for you to know that the particle is in equivalent or in equilibrium rather, sorry, their sum must be equal to 0. Okay, the sum of forces. So in this case, one equation, since alpha is 40 degrees, summing up the x components, 100 plus sine. Why did we use sine here? Okay, since the alpha here is 40 degrees. So opposite of alpha for you to get the x component, this one. Okay? So 1000 sine 40 degrees plus p minus 2000 cosine 40 degrees, equivalent to 0. So solving further, we get p is equal to 889.3, and for r, r is 2052 Newton downwards. So as we said earlier, that the particles, in order for you to know that it is in equilibrium, the sum of the forces, the resultant should be equal to 0. In this case, particle A is 0. 150 Newton to the right, 150 Newton to the left. The sum is 0. If there are three forces also that can be closed into a closed polygon, that will be in equilibrium. Just like in this case for particle A. Also, if there are several forces, more than 2 or 3. So mathematically, for vector form, the sum of the resultant is force is equal to 0, and for the vector in the scalar forms. Next, we talk about the free body diagrams. We are to now draw specific bodies into specific uh, diagrams. Okay, so you can review this class one by one. No, imagine the particle to be isolated, and then indicate on this sketch all forces. This is crucial. No, this is crucial. One missing force, and then you are wrong with your solution. Label the known forces and the unknown forces. Like this one. We have here a crate weighing of 50 degrees. 50, sorry, nabubulol. 50 kilograms. So in order for you to identify the weight, 50 times 9.81. Okay, for the weight. Draw a free body diagram in the crate, the chord B, and the ring at P. So you can get here our center or focal point to be uh, the crate and then the ring B. Okay, the ring B. So in the case of crate, the summary of forces along the x-axis is 0. Why? There are no forces in the right or the left. So the summary of the force along the y-axis is 0. The weight is equivalent to the tension of the rope BD. Okay? The rope BD. So in this case, as we said earlier, 50 multiplied by 9.81, 498.5. Okay? Now for ring BD, for the ring B, rather, sorry, we will get the force of chord AB on the ring, and then the force C to the right, and then the tensile force of BD equivalent to the weight of the crate. So the summary of the force along the y-axis, negative 490.5 plus sine 45 degrees of the force of chord AB, or the force of A. So you have one equation, one unknown here, only force A. So solving further, we get 693.7. And then finally, for FC, negative 693.7 cosine 45 degrees plus the force C, unknown force to the right, that will be cosine 0 equivalent to 1. So solving further, we will get 981.0. So for another example, another book problem class, we have here the crate of 200 kilograms and then the rope C. So in order for us to identify or to draw the free body diagram, we have this illustration. Okay? Now, in order for us to get the equilibrium, the summary of the forces along the x-axis and the y-axis is equivalent to 0. Then solving further, we'll have the following. So medyo mahaba. Okay? Fy is equal to FBC sine 75 degrees is 1. And then FAC cosine 75 degrees for this one. This rope. Okay? Let me delete first so you can see properly. This one is the cosine, the sine, the y-axis for rope BC, and then FAC. Bakit cosine? Because we have here the adjacent of cosine 75 degrees. That will be this one. Okay? Negative. Okay? Pointing downwards. Minus 1962. What is 1962? That is equivalent to your weight. Okay? 1962 times, 200 multiplied by 9.81. That will be 1962. So here we have here one equation with two unknowns. Okay, two unknowns. That's why we need to get another equation from equations 1 and 2 in this equation. So from two equations, two unknowns rather. So this one from the sine law, rather for the summing of force along the x-axis, FAC sine 75 degrees over cosine 75 degrees. And we will get now FAC is equal to 587 Newton. And then solving further, we will have FBC 3.73 multiplied by 587. Okay? So that will be it for our lecture 3. And wait upon my problem sets for your practice and solutions. Skills development class. Again, always spend time in solving problems in order for you to be better and good in statics of rigid bodies. Thank you all and God bless you all.